Assalamu alaikum. Hello everybody. This is an exercise, a theorem in a form of an exercise and some applications. Let UN be a real positive sequence. Show that if UN plus 1 over UN converges to L, then the nth root of UN converges to the same limit. How about the inverse? And as application, we will try to find the limit of these sequences. So we are concerned now by proving that if UN plus 1 divided by UN converges to L, then the nth root of UN converges to L. We already saw that if the limit of Vn is equal to L, when n goes to plus infinity, implies that the nth root of V1 times V2 times Vn converges to the same limit when n goes to plus infinity. This theorem is as an application. Why? Because we define a new sequence using this one. We define V1 equal U1, V2 equal U2 over U1, and so Vn equal to Un divided by Un minus 1. Don't forget that Un is a positive, real positive sequence. Then if Vn converges to L, Vn is actually Un divided by Un minus 1. If this sequence converges to L, this implies, using this theorem, that U1 times V1 U1, V2 U2 divided by U1, and so on, Un divided by Un minus 1. Here we have U1 cancelled with U1, U2 with U2, Un minus 1 with Un minus 1. So this nth root is actually Un, just Un. So if Un divided by Un minus 1 converges to L, this implies that Un converges to L as a simple application of the relation between a sequence, a positive sequence Un, and the nth root of U1 times U2 times Un. Don't forget that if and only if we have here Un converge, this is equivalent to Un plus 1 converge, this is equivalent to Un plus 2 converge, and so on. So here we have equivalence between them. This means that if Un divided over Un minus 1 converge, this is equivalent to say that Un plus 1 divided by Un converges also. This proof of the first question. This is the answer of the first question. Here we vowed to give a direct proof by considering repetitive inequalities, double inequalities. So what we did, we give proof using a previous theorem, which is more nice and more elegant. Yeah, this is the word. How about the converse? Actually, the opposite implication is false. If we have, we can get result about un. The answer, it can goes to n, but un plus 1 divided by un isn't converging to n. Here we have a counter example. We have a counter example. I prepared it previously. Let un be equal to n to power minus 1 power n. So we have here two powers, 2 power minus 1 power n. The nth root of un is equal to 2 power minus 1 over n divided by n. And when n goes to plus infinity, this goes to 0. So 2 power 0, this is equal to 1. But un plus 1, divided by un, this is equal to 2 power minus 1 power n plus 1 divided by 2 power minus 1 power n, which is equal to 2 power minus 1 power n plus 1. We take this here, minus times 2 minus 1 power n, which is equal to 2 minus, so we can take plus 1, this is plus, and here plus 1, times, so we have 2 minus 1 and plus 1, and this is equal, if n is even, so this is odd, negative, we have 1 divided by 4. If n is odd, the sum is even, this is plus 1, so we have 4. From side we have 1, and from another side we have 2 limits, so the sequence is this sequence as a cushion is not convergent, and even we have 2 different limits, so this we have 2 subsequences which goes to 2 different limits. Then the opposite implication is wrong. Using this implication, can we find limits of these 4 sequences? Let us get started by the first one. Name un divided by the nth root of n factorial. This we can write it as the nth root of n power n, to cancel this, divided by n factorial, divided by n factorial. Yeah, this is the exercise. Here this will be, so we try to find this limit. This limit we can write it like this, so un, so un, to be able to find the limit, un is n power n divided by n factorial. If un plus 1 divided by un converges to L, so is un, which is n power n divided by n factorial. The nth root, this means the nth root of un, this one, and this one is exactly what we need to prove to find the limit. This is equal to un plus 1. un plus 1 means n plus 1 power n plus 1 divided by n plus 1 factorial divided by un, so we multiply by the inverse. We have n power n by n power n power n factorial, sorry, n factorial divided by n power n. What we can remark, n plus 1 factorial, n plus 1 times n factorial, it will be cancelled with n factorial, and n plus 1 with n plus 1. So the final result is n plus 1 divided by n power n. This is equal to 1 plus 1 divided by n power n, which converts to exponential 1 when n goes to plus infinity. So the limit of n divided by the nth root of n factorial converges to exponential. Yeah, this is nice. This is nice. How about the second? How about this one? The same technique, actually, because we are faced to apply this technique, this theorem. The second one, so we search to find the limit of this 1 n, the nth root of n times n plus 1 times 2n. We can write it in the following formula: nth root n plus 1 2n divided by n power n. So we need to find this limit. We will consider un as this Russian, and we will apply the technique. This means that we have un plus 1 divided by un. This is equal to n plus 1, n plus 2. We replace n by n plus 1, 2n plus 1, and 2n plus 2 divided by n plus 1 power n plus 1 times n power n divided by n plus 1 2n. What we can cancel here, we can cancel all these terms with all these terms, and we cancel n here to put here minus 1. what we get. What we get. We get. Here we have 2, so we can put it here, plus 1. We cancel n plus 1 with 1. Then this will be equal to 2 divided by n plus 1 here times n divided by n plus 1 power n. Now here I am wrong, so we keep to n plus 1, so 2 times to n plus 1. Yeah, this one we cannot consider it because we haven't an equivalent here, and here we have 2n plus 2. This means 2n plus 1. So this is okay. This is equal to 2 to n plus 1 divided by n plus 1 times this will be we add the 1 and we take it off, so plus 1 minus 1. We get 1 minus 1 divided by n plus 1 power n. When n goes to plus infinity, this converges to 4 exponential minus 1, which is 4 divided by exponential, Euler constant. As a conclusion, the limit of this sequence converge to 4 over e exponential constant. Simple technique. How about this one? We will use the same technique. We have 1 divided by n, the nth root of 1 times 3 times 2n minus 1. We can write it as the nth root of 1 times 3 times 2n minus 1 divided by n power n. So un in this case is this one. What do we have? We have un plus 1 divided by un. This is equal to 1 times 3 times 2n minus 1 to n plus 1 divided by, we replace n by n plus 1. N plus 1 power n plus 1 times the inverse n power n divided by 1, 3, 5 to n minus 1. We can cancel here. We can cancel all this term with all this term. And we can write it under the form to n plus 1 divided by n plus 1. We take 1 from here, so it's still n times n divided by n plus 1 power n. As we already did, this goes to 2 and this goes to exponential minus 1. So we have here 2 divided by e. This is the limit of this one. How about the last one?